Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Modeling and Simulation of Bidirectional DC-DC Converter for Battery Charging and Discharging Applications. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in the domain of uh, battery energy storage system, which is the current research area inspired from managing the renewable resources, especially the solar panels and other sources. So here we have designed a bi-directional DC to DC converter using the PI controller. So let's talk about the work. So before starting the video, let's talk about what we will cover into this video. In this video, initially we will talk about in which application areas the design system can be helpful. Secondly, the model that we have designed, how to execute it, what are the software requirements for that. Later on, what we have designed in the current system, what is in the proposed method, and what are the findings. Finally, experimental outcomes and results will be shown. So let's start with the application areas. So the design system is specially related to the solar based system to store the energy in the BESS, and both way things is to be done, like charging and the discharging of the BESS. So a DC to DC converter is being designed. So the system is specifically for the solar energy management, or you can see currently like electrical vehicles and other areas has been explored by using the solar power to charge the batteries. So but the batteries in the electrical cars are smaller, so this can be a domain, but specifically it is for the grid based system where the electricity or the power generated from the solar panels is saved to the BESS. So BESS are basically the battery energy storage system. These are the big boxes like this in which the power is being stored and is further used in order when there is no enough power is available at the sources. So this can be implemented in many of the areas, like for the power stations, for transmission and distribution lines, for the substation, for the utility grids, even for the industrial solution, residential use, commercial use. So all these areas are the application areas in which the best systems can be implemented. Now the challenge is like how to manage the charging and the discharging of it. What systems can explode it, right? So that what we have designed a DC to DC bi-directional converter, because the converters generally available are only either charging or either discharging. So that what we have done. So the system that we are going to give you will have the code folder with them in which the model design is available. In order to run the model is designed in the Simulink of the MATLAB, so you must have the MATLAB software with you. The current MATLAB version that I am using is MATLAB R 2019. So you can use 18 or 19 above the 16 one in order to run the model. The previous version can also run the code, but in that scenario you still need the latest version and then export them to the previous version in order to run in the later previous versions of the MATLAB. So I recommend 2016 or above. So in order to run the code, you just need to copy the path of the folder and go to the MATLAB and just paste the path here and press enter. When you will press enter, you can see you are able to see the model. So this is the model that we have designed. So I am just opening it. You just need to double click on it and it will be ready to execute. So this is the model that we have designed, in which this is the best system, and the rest all whole scenario has been designed in order to see that how the same model is capable of charging and discharging at the same time of the best, so that the requirements can be fulfilled. So what exactly we have done in the current system? There are certain applications, those are currently working in the domain of the best systems, but the developing a bidirectional DC to DC converter is the main challenge of our research. So in this basically method, let's see what we have proposed. In the current scenario, we have designed a model where there is a power source which can be any, but here we are considering it as a solar power source. So from the solar power source we are getting the input and sending it to the ideal switch, where it is further sending it to the load and charging. Here the main contribution of the work is like in this section where the charging and discharging of the thing is done. So this is basically the MOSFET which is doing the work of switching the system. So let's explain this, that what we have done here. A battery bus system has been implemented which gives us state of charging and discharging, along with showing us the result in terms of the current and the voltage. So now exactly what is happening, when the system gets switched on here, when power source is available, then and here if the constant value is set to 1, it means there is input power which is used to charge the bus. So it will send the data to the model, and from which it will send to the VL is basically the voltage level that we are receiving, and it is compared with the reference threshold. The threshold that we have set is to 48, which is further comparing the voltage and giving us the condition that whether it is to be charged or discharged. Similarly, the second scenario is for the VB, in which we are getting whether the IB is for charging or discharging. IB is the current, basically this is for discharging decision, this is for charging decision. These two inputs is being given to the this model, where it is checking that whether there is a source or charging flag or discharging flag. On that behalf, that particular value is sent to the model, which is compared with the actual input we are getting at the system. So comparing these two models, we are getting the a decision of generating the duty cycle, in which we are using the PI controller to decide that. So one of the thing that we have introduced into this in order to design the bidirectional DC to DC converter is like we are using the PI controller. So this PI controller is helping us but decisioning of generating the duty cycle, so that the PWM can be there in order to give the input to the MOSFETs to get switch on or off. So this PWM is sending a positive and the negative signal, which is positive is the directly input that we get from the PI controller, and negative is the inverse of the signal that we get from the PWM. So this PWM input is given here, where this rate transition is sending the input to the MOSFET switch. So positive is given to the upper switch and negative is given to the lower switch, which help in switching the MOSFETs and deciding that whether the BESS BESS battery is to be charged or discharged. So let's see the simulation. So when I'm running this, currently the power source is on because I set this value to 1. So when I'm running this, you can see the value we will get at the scopes are state of charge, voltage level, and other things. So you can see currently the scope is like this, in which the initial power of the voltage was set to 45, and as the power source is there, so it is starting charging, and as the time is passing, you can see it is charging. As the battery is getting charged, the current value will obviously there will be a variation among that, and it will go down because load is attached at the output, and the voltage you can see it is also increasing. So now what I'm going to do during the simulation, I'm just changing this value to 0 to show that the power source get cut off. So you can see when I set this value to 0, it means the power source is cutted. Now let's see, the simulation is still running. So you can see as the power source just cut, the current get increased because the current now used is from the BESS system, which is within the battery, so it is higher because that is there at the output of the BESS, and the battery get discharging. So here you can see the state of charge of the BESS system is reducing because the load attached at the output here, the state of charge will be reducing because there is no input given to the power to get charged. So similarly the voltage will also reduce because the power available in the bus is discharging and is used by the load outside. So this is basically the system that we have designed in which the current same system will be capable to charge as well as discharge the bus system with the best capable input given to them, and decisioning is done by using the PI controller in it. So further modifications are still possible into it because the designing of the DC to DC bidirectional converter is still a challenge. So I hope this video is helpful for the research people in the domain of the handling renewable resources and saving the energy in the best systems. For more details, you can contact us directly and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.